In this video, we are going to analyze the gender gap in salaries in the American workplace and then use the holdout method to compare the predictability of different models. Here, the response variable is the salary in 1000s for 200 project managers in small to middle-sized firms in Boston area. We have also the size data, which shows the number of employees at the firm, and experience, which shows the manager's years of experience. Female binary variable equals to 1 if the manager is female and 0 otherwise. And grad is another binary variable, which equals to 1 if the manager has a graduate degree, 0 otherwise. For predictor variables, Model 1 uses size, experience, female, and grad, whereas Model 2 also includes interaction variables between female with experience, female with grad, and size with experience. And then we are going to use the holdout method to compare the predictability of both models using the first 150 observations for training and the remaining 50 observations for validation. I have already partitioned the dataset, so in this worksheet you can see that we have total 150 observations. In validation dataset, we have the remaining 50. First, we are going to estimate Model 1 using regression analysis. To do that, we go to Data and then Data Analysis and choose the regression. Our response variable is the salary, and predictor variables include the first 4 predictor variables for the first model. So we are going to choose size, experience, female, and grad. First row contains the headers, therefore we click on labels, and output range is in J2, and then click OK. So let's highlight adjusted R-square for this model. And next we are going to estimate Model 2, data analysis, regression. Response variable is the salary. Now for predictor variables, we have 3 additional predictors. Therefore, we select the data including that 3 additional predictors. Let's choose this cell for output and click OK. Let's highlight also adjusted R-square. So based on the training set, Model 2 is more suitable for prediction because it has a higher adjusted R-square than Model 1. Next, we are going to use estimated models to predict the response variable in the validation set and compute the root mean square error for both models and then compare. Here on this worksheet, you can find the validation data, which contains the remaining 50 observations. And also you can find Model 1 parameter estimates here and Model 2 parameter estimates here. We are going to use this coefficient estimates to predict salary first for Model 1 and then second for Model 2. Start with an equal sign and then select Intercept and fix the intercept. Slope coefficient for size, fix the slope, times the size, plus coefficient estimate for experience, times the experience, plus coefficient estimate for female times female dummy plus coefficient estimate for grad times grad dummy. So predicted salary for the first observation is 113.29. And next you drag down this formula. To calculate root mean square error, we need first differences between the salary and predicted salary. So salary minus predicted salary, enter, and drag down this formula too. Error squared is the square of errors. Click this cell and then square. Drag down this formula too. Mean square error is the average of squared errors. Select the data range and close the parentheses. And root mean square error is the square root of mean square error. So 11.30707 is the root mean square error for Model 1. Now we are going to predict salary using Model 2. Intercept plus the slope coefficient of size times the size plus the coefficient of experience times experience plus coefficient of female times female plus coefficient of grad times grad plus coefficient of first interaction variable times the first interaction variable and then the second one and the last one. and then enter. The second model predicts the salary to be 106.124 for the first observation. We drag down this formula, and next we calculate the errors, salary minus predicted salary, and we drag down the formula. Next we calculate squared errors, and again we drag down this formula. Next one is the mean squared errors. We can use average function here and select the data set and close the parentheses and enter. Root mean square error is the square root of mean squared error. SQRT function. So we have two root mean square error here. For the first model, it's 11.31, and for the second one, it's 12.60. And interestingly, model 2 with a better performance in the training set does poorer in the validation set because its root mean square error is greater than the first model. Based on these results, model 1 would be preferred for prediction.